go ahead and start my recorder. And in case he gets here in a minute, I'll share my screen for my online guy. But what we were saying yesterday, fellas, about this section is that you want to, we looked at some examples where the denominators were already the same or were already really close to being the same, right? And we said that once they're the same, you just go, across the top, and that's all good and well. But once in a while, you have to figure out, okay, well, what should their denominators be? And we said you could use inspection a lot of times and just kind of eyeball it, and that's good. That's oftentimes a quick enough way of doing it. But we also want to fall back upon a process by which we, if we can't just eyeball it and see what the LCD is, we can at least, fall back on that process. So we started example 4. We found our LCD here in red should be x minus 3, x plus 1, x plus 3. So the next question I like to ask you guys is, and I would write this down if I were you, what is now missing from each denominator? Say, what's missing from each denominator, okay? Now, what I mean by that, okay, is that if my LCD over here in red is the goal, you look at each denominator and you decide what factor is missing. Hey, George. Here we go. Come on in, buddy. So from that first denominator, we got a couple factors that are already present, right? We got x minus 3, we got x plus 1. So what's missing? There's 3 factors that I'd like to have. My LCD there's x minus 3, x plus 1, and x plus 3. So what's missing from that first fraction? Okay, well, let's see here. Is there an x minus 3 in the first fraction? Check. Is there an x plus 1 in the first fraction? Check. Is there an x plus 3 in the first fraction? No, that's what's missing, in other words, okay? So what we want to do is we want to multiply by a clever form of 1. You've heard me say that a bunch of times so far. So like when I changed this first fraction, it was 8 over x minus 3x plus 1. So now I'm going to artificially put in an x plus 3 on the top and an x plus 3 on the bottom, okay? That, in essence, is not changing the value of that fraction. It's just making it look a little different. That's like if I were to say 1/2 plus 1/3, and we want the denominator to be a 6. Hey, can I help you? What's up? Do I know what? Yeah. Come on, I'll show you where it's at. Down this hall, you see where that guy's walking? That door right there on the left is... Yeah, Coach Smith. Coach Smith, are you Sipes? Hey, show him where Math Lab is, please. It's room 108, buddy. Sorry, fellas. Sorry about that. But do y'all get why I put the x plus 3 on the top and on the bottom? It's like when we were saying, let me get this complicated example out of the way. It's like when we were saying earlier, like if I wanted 1/2 plus 1/3, right? I would change this first fraction by multiplying by 3 over 3 and temporarily unsimplifying it to make 3/6. And then over here we'd multiply by 2 over 2 and we'd make it 2/6 so that it has the same denominator. Those are both unsimplified fractions. This is an unsimplified fraction, right? It's got the same thing on the top and the bottom that we would normally get rid of if simplifying. We are unsimplifying it for the purpose of combining it with this other fraction, okay? Now, if I wanted to combine it with this other fraction, what's this other fraction going to be? 3x. Okay, so x plus 3, x plus 1. You guys tell me from my LCD what's missing. Now we're cooking. Good. So I would artificially put in an x minus 3 on the top and on the bottom. Okay. That's not changing the value of the fraction. That's giving it a facelift. That's letting it look a little bit different. So that now it's got, each denominator has all 3 of the factors needed from my LCD. Okay. Now that the denominators are the same, sound effect, please. Oh, thank you. What the heck
think is wrong with you guys? Huh? Number one, you hadn't seen one of my favorite movies, Groundhog Day, except for a couple of you guys. And then number two, you daggone forget my funny little sound effect. Once the denominator is the same, across the top. And what that's going to look like then is doing a little bit of distribution, right? So let's do some distribution. We got 8x. We got 24. That looks like a 29. Hold on a second. 24, much better. What do we got? 3x times x is 3x squared. And we got negative 9x. All of that's over x plus 3, x plus 1, x minus 3. Okay. Now, from yesterday's lesson, or last week's lessons, excuse me, we learned how to simplify a fraction. All I did, by the way, up here in orange is I distributed the 8 in the first group, 3x in the second group, and then I added those two resulting binomials, okay? Adding's easy. We like adding. We don't have to worry about changing any signs. We just tally everything up. Now, how could I maybe reorder that numerator? And don't be shy. Speak up. Speak up. What do you think, James? So 3x squared minus 1x and plus 24. Very good. He combined a couple like terms. He put it in proper order. So I like that a lot better. And now I'm kind of curious. I wonder, does that factor? Okay. And if I'm going to try and factor this, I'm going to use the magic method. Very good. Because we see that leading coefficient of 3 and we think, oh, I got to do a little magic method here. Let's take a time out. I don't know if this one factors or not. This is the first time I'm working this problem with you guys. Hadn't worked it in a year. So let's see. Pretend like it's x squared minus x plus, now what's 3 times 24? 72. Oh, mama. 72 is a big one. It's got a lot of factors. But I bet 8 and 9 would work. What do you think? X minus 9, x plus 8. And we're going to bring a 3 back. And we're going to get x minus 3. Hot dang! You know what? We're going to have something canceling out. We got x minus 3. We got 3x plus 8. And then x plus 3. Plus 1. X minus 3. Drew, what cancels? That x minus 3 is going to cancel out. Get out of here. And we got 3x plus 8 for x plus 3, x plus 1. Ooh, mama. What a good-looking problem that was. There we go. So think about everything that we did. I can't even barely fit it in the screen. Think of everything that we did right there. We found the LCD first. We changed each fraction such that it would have the same denominator. Then we went across the top. Then we simplified and or factored and simplified it out there. Go ahead with your question, Jack. Oh, shoot a monkey. Did I screw that up? Dadgummit. Okay, good catch, Jack. I was getting all giddy thinking it was going to cancel out. Let me reassess this. It probably doesn't factor in there. In that case, I'm going to be greatly disappointed. All right, hold on. Shame on the rest of you. Why didn't y'all all yell at me when I did that? Jack, I love you. Thank you for pointing that out. Let's do the long way. 72, 2 and 36, 3. We already talked about 3 and 24. It's divisible by 4 and what, 18? It's not going 5. It does go 6. 6 times 12. 7, no. 8, yes. 8 and 9. Oh, you've got to be freaking kidding me. It doesn't factor. That's so disappointing. Oh, well. I guess I'll have to scratch all this good-looking, fancy, fun, canceling out math away. What do I need to leave my answer as then? Y'all can tell I'm so disappointed. Jack, thanks for peeing in my Cheerios there, bro. What do I have to leave it as? 3x squared minus x plus 24 over x plus 3, x plus 1, x minus 3. Now, in all seriousness, Jack did a great service to us. He pointed out a couple things. Number one, we want to make sure we get the problem right. Number two, it's easy to rush and make a mistake, isn't it? Even, like, obviously, I'm a math teacher. I know what I'm doing. But, you know, it's easy for us to make mistakes if we're not paying attention, right? Or if, you know, we're rushing through the problem trying to get to the next one, okay? So take your time and do it right. That's a very unsatisfactory answer because it did not demonstrate or illustrate that last step, which is oftentimes factor the top and see if anything cancels. And it was just, oh, it's going to be a beautiful day, Jack. It was going to be a beautiful day. That's okay. It still will be. All right. So the process again, keep in mind, and I just kind of went and ticked them off on my fingers. You might write the process down. The first step we said in this kind of problem is finding the LCD. That's the first step, right? Find the LCD. I saw 2 pencils start moving when I said write these steps down. Find the LCD. That's step numero uno, okay? Step number 2 is change each fraction. And that's where we multiply by a clever form of 1. Whether it's x plus 3 over x plus 3, whether it's x minus 3 over x minus 3. Okay, so we found the LCD, step 1, change each fraction, step 2. Third step is go across the top. I don't know how you're going to write that down, but just, you know, add or subtract the numerators. When I add and subtract the numerators, what do I leave alone? Good, I don't change the denominator at all, do I? Right? That's step 3. And then step 4 is to simplify the final fraction. And that involves combining like terms, factoring if it does factor. This one didn't, sadly. But factoring if it does factor, and then seeing if anything cancels out. Okay? Seeing if anything cancels out. Yes, sir?
I could get the x squared minus x.
Ooh, that's a great question. I forget who did it for me. James? James, can you explain how we got 3x squared minus x plus 24? Mm-hmm. Mm-hmm. So what he did was he listed the 3x squared term first. So using the commutative property, we listed this term first. Then he combined, as he said, the 2 linear terms. 8x minus 9x gives us negative 1x. And then he listed the constant term last. Great question, great explanation. All right. Anybody else? All right. Will Edwards, how are we doing today?
Good.
Hanging in there like a hair in a biscuit?
Yes, sir.
Oh boy. You got no idea what that even means, do you?
No, sir.
You ever had to make biscuits?
I don't think so.
Man, I'm gonna tell you what, Mrs. Morgan, my mother, not my wife, my mother, makes some good homemade biscuits. And so every once in a while, I'll try my hand at it, okay? Because my wife, Mrs. Morgan, the younger one, likes canned biscuits. Y'all ever eat canned biscuits? You know what I'm talking about? Canned biscuits are good. But once in a while, it's just nice to make something from scratch, I think, just as a good culinary exercise. Okie dokie. And so I'll make them from scratch. And one of the things about biscuit dough when you make it from scratch is that it's very sticky. All right, like if you're rolling it up and you're flattening it out, if you don't have flour on your hands, that dough is going to stick to your palms. Okay, so hanging in there like a hair in a biscuit is, imagine you got this sticky biscuit dough and one of your hairs falls out and lands in the biscuit dough. Okay, good luck picking it out because that dough is very sticky, and so that hair is going to stay in there. So when you say hanging in there, you know, like I'm staying tough, baby. I'm hanging in there like a hair in a biscuit. There you go. You guys have learned how. What do you call it? A colloquialism. Nice. All right. Some of you, having already written example 5 down, are probably on your way to changing each fraction because the LCD here is very, very simple to find. Okay. Each denominator is already factored. They don't have any common factors. Okay. And so I'm going to make a note, and I'm going to say when the denominators share no common factors, the LCD is the product of the denominators. In other words, just multiply the denominators by themselves and you get the LCD when they don't have any common factor. Now, you've actually known that since elementary school. For example, 1/7 and 1/8. Okay? Those don't have any common factors. 7 and 8 don't have any common factors. 8 is the same thing as 2 cubed. 7 is prime, so it's just 7. So what's the LCD? 56. That's an old trick. That's easy, right? Because you multiply the two to get the common denominator. What if instead of 7, though, what if this was 10? Is the LCD 80? No, because 10 has a common factor of 2, and so you would do either inspection in C40, or you would do your process by which you factor each denominator out, circle each new factor raised to the highest power, and away you go. In this case, look, x minus 3 is unique. It is a new factor. Nowhere else is it listed to a higher power, so we're going to include it. X minus 2, same deal. So the LCD here is the product of both of these. So my LCD for this example, x minus 3, x minus 2. Nate, what's missing from that first fraction? It's got an x minus 3. What does it need now? Yeah, buddy, it needs an x minus 2. We're going to daggum give him one, okay? If he needs it, we're going to give it to him. So I'm going to change this to 3 quantity x minus 2 over x minus 3, which was originally there, and x minus 2, which we're artificially putting in there. We are temporarily unsimplifying a fraction so that it can play nicely with the other fraction. Okay? Quentin, how about that second fraction? What do you want to put on the top and the bottom? Yeah, it's already got an x minus 2 on the bottom, so it needs an x minus 3. So we're going to put one on the top and on the bottom. Now each denominator is identical, okay? So Mossy, what's the next step after I've got my LCD set in place for both fractions? Across the top before we simplify, okay? And I know that, like I said, that sound effect is hard to write down. What is that called? What part of speech is that? An onomatopoeia? Is that what you guys learned? Oh, I love a good onomatopoeia. Don't ask me to spell onomatopoeia, but I can say onomatopoeia all day long. Onomatopoeia. All right, Andrew, you want to combine some like terms?
That's 5x minus 12.
5x minus 12. Does that factor any further, class? Does 5x minus 12 factor anymore? No. So we done. And again, sadly, I skipped over that last step, as Mossy mentioned. Simplifying. There's nothing to simplify. Okay? 5x minus 12 is all she wrote. Now look, what we're doing right now, you guys are making some baby steps. Okay? You're building up some skills here. I want you to try now to put those skills into action. Try now to put these skills into action. And I'm going to warn you that this one is a little tougher because it is a subtraction problem. You're subtracting, so be careful. Quentin, I would be happy to zoom in, Quentin. How about that? You're welcome. Junction, what's your function? Y'all ever listen to Schoolhouse Rock? You guys know what that is? Miss Betsy Morgan, my 7-year-old, is all about some Schoolhouse Rock. I'm just a bill, and I'm only a bill, and I'm a bomb. When I was a kid, my favorite was about 3 is a magic number. It would teach you how to skip count by 3s. And these big burly football players, they would bust through a wall. And all of their jersey numbers were multiples of 3. Life was simple back in the 80s and 90s, I'm going to tell you. It was great fun. Your teacher would wheel in a cart with a huge TV on it with a cathode ray tube in it.
You could go to town learning. I like how I'm seeing a couple of you guys up here near where I'm at writing out what your LCD is. That's a solid step, right? It's helpful to write that up there because your eyes will see easier when it is written down what perhaps is missing from one or both of the fractions, okay? In this particular example, your first fraction is actually going to be set up with the LCD already in place. Did you notice that? Right? Your first fraction's denominator has everything that it needs, so you will not have to change your first fraction around. This is only where you have to change the second fraction. That's like if I said, hey, what's 1/5 plus 1/10? You know, you don't have to change the 1/10 because it's already got 10 as its denominator, and that's the LCD in that case. Okay. Let's see here. Oh, Joey, can you factor my first denominator? That's my first step. If I can't get that, I'm stuck no matter what. Very good, very good. Y plus 4. Remember, that's the difference of two squares, isn't it? If I can't factor, oh, mama, I'm going to have a hard time. Now, the LCD, I go through, and I can either use my process, circling each new factor raised to the highest power, or I could just recognize, well, hey, look, if I put a y plus 4 over here on this second fraction on the top and on the bottom, then we're good to go now. Each fraction has the same denominator. Did you notice that? Okay, so we only had to change that second fraction. We multiply by y plus 4 on top, y plus 4 on bottom. Don't fall into the temptation to go ahead and multiply these denominators out. Please leave the denominators factored, okay? So I'm going to write up what we've got up to this point. I got 8y minus, and then 4y plus 4, all over y minus 4 and y plus 4, okay? Here's where we make mistakes, though. We must be very careful. When we distribute this 4, a lot of people will just say that's 4y plus 16, okay? 4y plus 16 is great, but what am I doing to that numerator? What operation are we doing to that second fraction? We are subtracting it. And if I said, dadgummit, Alex, I'm just sick of your road, get it out. You know, we talked before. I'm not just going to take the first guy out. I'm going to go through and subtract each and every guy in that row. If I'm subtracting a fraction, please listen to me on this, fellas. If I'm subtracting a fraction and the numerator of that fraction is a polynomial, many terms, I've got to subtract each term. I've got to go through and take out each term. And that means changing their signs. The way that I think is a little bit smarter to look at it, watch this. I would recommend just distribute the negative with the 4 and you will not forget. Distribute the negative with the 4 and you won't forget. There's no way I'm going to forget. Now I got 8. Ooh, that's too fat. Hold on. There we go. We got 8y minus 4y minus 16. All over y minus 4 and y plus 4. Okay. Now what we want to do is simplify. So George, simplify my numerator, please. What's 8y minus 4y? So I got 4y minus 16. Alex, can I factor that numerator? I know this one factors, unlike that stupid last one that Jack called me out on. GCF, what's in common? On the numerator, you think both of these terms have a y in them? Ah, how now, brown cow? We take out a 4 and we're left with what? Now you took out a 4. All right, so y minus 4. And then, ooh, what do I notice, class? I finally get to do what?
I get to cancel. I get to cancel. What am I going to cancel out? Y minus 4. Y'all are like, please don't ever do that again. All right, so our final answer over here was 4 on top and y plus 4 on the bottom. But wait, Coach Morgan. You have to remind me what my restrictions are. Why can't be what? Paul? Or -4 would screw up the final denominator. Jack McBee? +4 would screw up the original denominator, and we want to restrict y accordingly. So y cannot equal plus or minus 4. Okay, those are our restrictions. And please remember, again, the context of the problem is going to dictate whether or not you have to list those out. Your teacher in your middle school might not even care about them. That's fine. Okay. Notice our instructions. Our instructions didn't say anything about them. But it's a good habit to understand and to list out what restrictions are just in case. Okay, you know what I'm saying? It will help you in Algebra 2 and in pre-calculus one day. I promise you. If you already have this background understanding of what your variable can't equal in a particular expression. Okay? Last example, and then the lesson will be ours. Or yours, I guess. Now, we're going to work this one together. This one's our first. What's a little different about this one? 3 fractions. Are we going to lose our mind? Or are we just going to take it one fraction at a time? A little disconcerting. I'm not getting any answers out of you guys. We're not going to lose our mind, Coach Morgan. We are going to be careful, though, because we're subtracting one of those fractions. Okay? First step, I like how y'all write the problem down. Of course, that goes without saying. But our first step is going to be factor every denominator. Factor everything. So the first denominator needs no factoring. It's just u minus 1. The second denominator needs no factoring. It's just u. How about the third denominator? Factor it. U and quantity, u minus 1. Good. Another GCF question like we had a moment ago. Okay. So now I'm going to go ahead and write out my LCD since I know that's a good step to do. My LCD is going to contain each new factor raised to the highest power. And then I'm going to multiply each of those. So the LCDs are going to be u, quantity, u minus 1. Okay? So u, quantity, u minus 1. Which of those 3 fractions is already set up good to go for us? The last one. Yeah. All right, so Luke, you're going to tell me what's missing on the first fraction then. It's got a u minus 1. What does it need now? It needs a u. So I'm going to give it a u. And I'll rewrite it over here in blue. So we're going to have a 2u. Now, there's already a u up there, so if I put another u up there, can I just go ahead and make it u squared? Y'all okay with that? All right, so u minus 1. Okay, Grove, what's missing from the middle fraction? Good, so there's a 1 up there. Do I really have to show the 1 times quantity u minus 1, or can I just put u minus 1? I'll definitely go ahead and put u minus 1. And we put it on the top and the bottom because that's a clever form of 1, or uno in Espanol. Also, my kid's favorite card game at the moment. Jenny loves playing uno. Lastly, do I have to change this fraction any? No. No, I do not. Now all 3 denominators have the same factors in them. They are all identical. And we did that slowly, step by step, changing each fraction as needed. We found the LCD, we changed each fraction accordingly. Now we're going to sound effect. We're going to go across the top. Here's where we have to be careful though. Okay, cuidado in Espanol. Caution. Okay, 2u squared plus u minus 1. Pause for dramatic effect. Joe Edwards, what now? Ah! All right, let's see if Reed can. You fell into the pit of despair. Congratulations, you're down in the pit. Reed, you're going to join him, or are you going to rise above it to the mountaintop of serenity? So we're going across the top, and we've taken care of this. We've taken care of this. Now what? Dadgummit, I'm just sick of your old get out. I'm subtracting a binomial. Joe, you want to claw your way up out of the pit of despair? No. He's like, no, I'm happy down here in the pit. I fell in the pit. Y'all seen Parks and Rec? Anybody? That's an old reference. There we go. All right, Paul. What? What? Welcome to the pit, brother. Okay, Quentin. Gosh, doggy, y'all don't just distribute the negative into the binomial, for Pete's sake. Jake. Minus 2u plus 1. Okay, Joe, you forgot to distribute that negative. So you said minus 2u and a minus 1. When we distribute that negative, it's going to change both of those signs. And then we can go ahead and combine like terms. That's what we were doing. That's all good. That's what you get for thinking, as my dad would say. All right, what do we got? We got 2u squared minus u, and that's it. Because the 1 and the negative 1 cancel out. U minus 1. All right, what's my next step, Drew Benton? We're going to factor the top. All right, we're going to factor the top. Luke, factor that top for us. And what's left over when you take that u out? I didn't quite hear you. I don't think I don't think what you said was maybe as accurate as you want it to be. Divide each of these by u. What's 2u squared over u? Louder. What the dump happened to the 2? 2u. Look, we got 2u squared minus u, and we are mentally dividing each of these by a u. So we would scratch out that. We'd scratch out that. So we got 2u minus 1. And how could I double check to make sure that we did that right? Yeah, just distributing that u back in is going to get us to 2u squared, and it's going to get us to negative 1u. Does anything cancel now after we factored? What do you think, Mr. Candiato? Can I cancel something now? Absolutely. All right, so my final result here would be 2u minus 1 over u minus 1, as long as u does not equal 0 or 1. Okay, why 0? What would 0 mess up? Yeah, that middle fraction at the very beginning. 1 over 0 is undefined. It would mess things up. Ooh, we're out of time today. I held you guys a minute and 10 seconds too long. All right, pack it up, pack it in. We have finished this lesson, so check Delta Math for a homework assignment on adding and subtracting fractions. Thank you very much for a good class. You guys are rock stars. Well, dadgum, Charlie, I guess you're just going to walk out while I'm talking? Stop walking, Charlie. Thank you. Quentin, be quiet. When will I see you guys again?
Friday.
I will see you on Friday. All right, thank you so much. Check YouTube on Thursday for a lesson. Live Jesus in our hearts forever. Bye, Charlie. See you guys. I fell in the pit. You fell in.